Let us master the strategies of solving related rates problem in calculus and enjoy the journey of learning with Anil Kumar. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are discussing a very important question based on related rates of change. The question has been provided by my subscriber. You can also post the problems. I will be in a position to provide you with solutions within a couple of days. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting excellent marks and admission to the best universities. Well, the question here is: a container is made up of a cylinder and a hemisphere as shown in the diagram. At the time when the radius is 6 centimeters, the volume is 684 pi centimeter cube. The radius is changing at the rate of 1.5 centimeters per minute, and the volume is changing at the rate of 1800 pi centimeter cube per minute. Find the rate of change of height at this moment. You can always pause and answer the question and then look into my suggestions. So, we are given this diagram where that is the cylindrical part, and as you can see, the radius of the cylinder is given to us as r, which is also the radius of the hemisphere on top of it. Important thing which we need to note here is that radius is changing, right? R is changing. Since we are given the rate of change of radius is, which is dr dt, is 1.5 centimeters per minute, right? So we are not writing units here. Height is this height which we are considering, height of the cylinder. Correct. It's kind of an ambiguity, but we'll just put height of the cylinder. So radius is changing and height is also changing, right? We need to find dh dt when radius is equal to 6. That is what we need to find from all other things given to us. So first, at this condition where r is 6, we should be in a position to find the height, right? Okay, which we can because we are given that if the radius is 6 centimeters, volume is 684 pi centimeter cube, right? Okay, so now let's write down an expression for the volume of this silo. So volume is volume of the cylinder, which is pi r square h, plus volume of hemisphere. Hemi means half of sphere, which is 4 by 3 pi r cube. Correct. So we could write this as volume as pi r square h plus 2 by 3 pi r cube. Since the volume is 684 pi, let's write down. Radius is 6 for us, so 6 square. Height we need to find plus 2 by 3 pi 6 cube, right? So we get an expression where everything is known to us, pi's will cancel, right? And we can now find out the value of h. So as you can see from here, let me rewrite final calculation 684 equals to 36h plus 2 times 6 cube. So let's multiply. 6 cube is 216, right? We'll multiply that by 2, which is 432. Correct? Divide by 3. We have to do divide by 3 also. So 432 divide by 3. 144. Correct. So 2 times 6 cube divided by 3 gives us 144. Okay. So 36h equals to 684 minus 144. So 36h is 0, 4, 5, and h will be 540 divided by 36, which is 15, right? So we get the height in this particular case at the instance when radius is 6. Okay, so if radius equals to 6, height is equals to 15. Very important. We got that. Now we'll move further. Find the derivative with respect to time and then also find the rate of change of height. Perfect. I hope it is absolutely clear up to this point. Okay, so height of 15. So here what I've done is I've written everything which is given to us. Radius is 6 centimeters, volume 684 pi centimeter cube, drdt 1.5 centimeters per minute, and we also find height as 15 centimeters. dv dt 1800 pi centimeter cube per minute, and we need to find dh dt when r is equal to 6. Perfect. Great. Now let's begin with the volume formula, which is pi r square h, that is the volume of the cylinder, plus half of 4 by 3, so 2 by 3 pi r cube. So now we need to differentiate with respect to time. Remember, both r and h are changing, so we need to apply product rule for the first term. So what do we get? We get dv dt equals to derivative of this. So you can say, let me first write pi is a constant, right? So pi is a constant. Derivative of r square will be 2r dr dt, right, times h, plus derivative of h. We have pi r square dh dt. So what we have done here, we have applied the product rule, right? Differentiating further, first with respect to, first we differentiated r square, then h. The next term here, differential, is 2 by 3 pi times 3r square times dr dt, right? Implicit differentiation. So we have an expression. This can be simplified. Okay. So we can now substitute the values given. dv dt is 1800 pi. So we are substituting the values. 1800 pi equals to pi times 2 times r of 6. dr dt is 1.5 times height. Height is 15. We calculated. Plus pi. Actually, we could have cancelled pi, but anyway, let me rewrite. Pi r square is 6 square. dh dt we want to find, plus 2 times 3. 3 cancels, right? 2 by 3 pi r cube, 3 r 3. So we get 2 pi 6 square times 1.5 for dr dt. Correct. Now let's cancel pi's, right? We could have done it earlier also. Great. So dh dt is the term here. We'll write down all the numbers. 1800 equals to, let's multiply. So we have 2 times 6 times 1.5 times 15, 270, plus 36 dh dt. And here we have plus 2 times 6 square, which is 36, times 1.5, 108. So from here we can, from 1800, subtract 108 and 270. That will give us 36 dh dt, correct? So this is 1800, take away 108 and take away 270. That gives us 1422, which is 36 dh dt. So from here we can find dh dt equals to 1422 divided by 36. 79 by 2, or 39.5. Units being centimeter per minute. Is that clear to you, right? A lot of calculations required. However, the critical part which I find is that when you do implicit differentiation, you have to differentiate R also for cylinder, right? I think otherwise it was not so difficult. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.